Okay, year 12, here we go. This is the graphs and transformations test video. So first one, you might of course be a bit like, what on earth are these funny lines here? And that's a modulus function that we will meet in year 13, but it doesn't really matter what that function is, it's the same in both things, and the fact that you've got the quarter there means you must have a stretch parallel to the y-axis. And the scale factor will be wherever that number happens to be, and so it was that option there. For this one, because you've got a, you can see if we multiply all this out, we'd have a cubic. It would be the positive coefficient of x cubed, so it would be this kind of shape like this. Now, subbing in x equals 0, that gives us 9, and so it's going to cross the y-axis at 9, so 0, 9. If you sub in y equals 0, you then get the 2 points where it's going to cross the x-axis, except this one won't cross, because this is going to be what we call a repeated root. So this must be the situation where it sits on the curve. And so there we go, that's your completed sketch. Y equals, so 0.50 there, no 0, 9 there, and 3, 0 here, and the shape. There was no requirement to find this point because it was only 2 marks. On to question 3. This one, so all that's happened is it's shifted up by 2, so nice and easy. Y equals 5 over x squared plus 2. For B, you need to get the shape of the curve. There we go. Like that, so that's one of the curves. The k over x squared is one that we need to be familiar with. And it's shifted up by 2, so that gives you a an asymptote at y equals 2 and an asymptote at x equals 0, which is the y-axis. Okay, nice and easy. On we go to question 4. So here we go, we can see this graph is now plotted on here. It did say to label all the axes and haven't the asymptotes, haven't quite finished that. And so this one along here, this will be an asymptote y equals 0. And the points where they cross the curve, well, this one, y equals 1 over x plus 1, fortunately doesn't cross the curve at all. But this one does, and so we've got there, we've got minus 2.5, and here at minus 1, and here at 3. So that will cross the curve at all those points, and we can see also that we've got 2 points where the curves intersect. So that means we've got 2 real solutions. On to question 5. So from GCSE, really, inversely proportional. As is convention, we always put time on the x-axis and the other thing on the y-axis, and so you can have that kind of shape with asymptotes on both of the axes. If Alex completes the race in 70 seconds, remember from what we were told previously, it's inverse proportion, so V equals K over T. Alex completes the race in 70 seconds at velocity 6 meters per second, so 6 is equal to K over 70, and so 420 is equal to K, and so that means that V is equal to 420 over T, and so for Dexter it's going to be V is equal to 420 over 5.6, and that works out to be 75 seconds. Okay, on we go. Question 6, so on to the ones with a bit more thinking here. If y is equal to 3 over x squared, stretch with scale factor 4 parallel to the x-axis. So when it's a stretch parallel to the x-axis, what we're going to have to do is we're going to take our x and we're going to replace x. So we're going to replace x with, it's a scale factor of 4, so we replace x with a quarter x. Alright, so that now means that we'd have y will be equal to 3 over a quarter x all squared, so that would be 3 and then 1/16 x squared, and then obviously we're dividing by a fraction, so we'd flip that over, and so that would give us 16 times by 3 over x squared. So therefore it would be the same thing as having a stretch the scale factor 16 parallel to the y-axis. Alright, so that's one thing they're making a point of on this question, and indeed the next question about different stretches. Now for this one, it's a little bit tricky. Clearly it's a sketch, a stretch. We can see that what our general situation, and we won't need too much imagining here. So there's y equals x squared plus 3, and y equals 4x squared plus 3 would look like this. So that would be y is equal to x squared plus 3, and this one would be y is equal to 4x squared plus 3. Okay, now you might think about a stretch parallel to the y-axis, but a stretch parallel to the y-axis would take every point to be further away from the x-axis, so it would stretch it further, and that'd be a problem because this point is on both curves. So that means it must be a stretch that is parallel to the x-axis. So in order for that to happen, because it's squared, what we would do is we'd replace x with x over 2. Alright, and so in that case we'd have y will be equal to, and this is just checking that it works, 4x over 2 whole squared plus 3, and so that would indeed be 4 times x squared over 4 plus 3. The 4's would cancel out, so that would indeed get us what we want. So if we replaced x with x over 2, this means that we've got a stretch, and we are parallel to the x-axis, and our scale factor is 2. So basically this one has been stretched out, so it'll be twice as far away. So we can kind of sort of see that there on my little sketch, that now every point is going to be twice as far away from the y-axis. Okay, moving on to question 8. Okay, so this one requires a little bit more work, and so because we are stretching with a scale factor 3 over a parallel to the x-axis, it's the same kind of situation. We are going to replace x in f of x with x over 3 root a. Alright, so we're dividing because that's what happens when we're stretching parallel to the x-axis. Alright, now notice you've got to know that just to get anything at all on this question. So this is something that we really do need to make sure we are aware of. Okay, so I've now got 54 a root a, that was there before, and now I'm going to, and rather than x cubed, I've got x over 3 root a all cubed, plus, so I've still got my 27a that I had before, but instead of x squared I've got x over 3 root a all squared, minus 51 root a, that was there before, but now I've got x over 3 root a, and we still got the plus 12, that's just hanging around there. At least for no reason we can see yet, maybe it will appear to be useful later in the question. Alright, so what's happening now? Well, probably best we get rid of these brackets, or at least the powers. So 54a root a times by x cubed over 3 cubed is 27, oh, that's quite nice, and root a cubed, that's going to give us a root a. Alright, you could have done a to the 3 over 2, but a root a is going to be better for obvious reasons that we'll do in a minute. We still got the 27a here, so the x squared over 3 squared is 9, root a squared is a, and then 51 root a was there before, x over 3 root a, nothing really to do there, plus 12. Okay, so now we can see we got some cancelling going on, and so 54 and 27, that will cancel down, just giving us a 2 there, and both those a root a's will go. The 27 and the 9 will cancel, giving us just a 3 here, and those a's will go as well. The 51 and the 3, all good darts fans will know that's triple 17 is 51, and the root a's will cancel out. 12 is still just hanging on, so that's going to give us 2x cubed plus 3x squared minus 17x plus 12. That takes us nicely to 10 minutes. Alright, and on to part B. Now, hence find the solutions to f of x is equal to 0. Now we've got, from the previous part, we've got our g of x, and that was 2x cubed plus 3x squared minus 17x plus 12. What they're going to want us to do here is to solve g of x is equal to 0 first. And so what I'm going to do, if we just have a little look at this, it's dead easy to spot. You could really put this into your calculator to find the solutions, but I'm going to revise the other technique here now. If you think I'm being an idiot and wasting my time, well, I don't think I am. It's dead easy just to spot here that g of 1 will be equal to 2 plus 3 minus 17 plus 12, so that will be equal to 0. So then that would then mean that x minus 1 is a factor by the factor theorem. Okay, so make sure you've stated that. Alright, now probably best to come in to use our grid method. So here we go. So we've got x minus 1 here because we know that that's going into it, and we know we're starting off with 2x cubed, and we know we're finishing off over here with plus 12. So I'll put those things in, and then from there on in we can work all this out. So that must be 2x squared. That means this must be minus 2x squared. I know I need to have positive 3x squared in the end, so that means this one must be plus 5x squared. If that's plus 5x squared, then in order to get that must be plus 5x, and 5x times minus 1 is minus 5x. I know I need minus 17x in the end, so that's minus 12x, which means this must be minus 12, and that would work nicely with this. Okay, so that now means that I've got one of my factors is x minus 1, and I've got my quadratic there is going to be 2x squared plus 5x minus 12. Now I want to factorize that. In order to do that, and again I'm just revising the basic technique here, like I said, you could have just used this on the calculator, but I think it's worth doing. So we can go, right, 2 times minus 12, that's minus 24. So I'm going to take our quadratic here, which was 2x squared plus 5x minus 12, and I'm going to break that up into things that will give us plus 5x, also multiply to give us minus 24, and that of course is 8x minus 3x. I can now do the factorizings on both of these, so that gives me 2x, x plus 4, minus 3, x plus 4. The x plus 4s are in both, so we can now collect this together. So I've got 2x minus 3 and x plus 4. So that then means that my whole thing would factorize to give me x minus 1, 2x minus 3 and x plus 4. Now that's all well and good, so that means my solutions to g of x must be x is equal to 1, x is equal to 1.5 and x is equal to minus 4. Okay, now to get my solutions to f of x, I just need to divide all these by 3 root a. So I'm going to have 1 over 3 root a. Then when I divide 1.5 by 3 root a, so I could write that down, so 1.5 over 3 root a. That will simplify because that will be 3 over 2, so the 3's will cancel out, which is going to give me 1 over 2 root a. And then lastly, minus, that's minus 4. Minus 4 divided by 3 root a, and that will just be that, so that's a 4. And there we go, so that's those ones. Like I said, you could have got your stuff divided and just divided by 3 root a, but revising techniques is good, so I've done that. Alright, for question 9. Now I know there was to sketch the diagram was in part B, but I've done it here in part A, just to try and get a feel for what the question was. So I can see I've got y equals 1 over x minus 3, and it has an asymptote across here, an asymptote down here at 3. I'm thinking, well, how on earth can y equals kx just touch it once? Because if it goes up through here, it's going to go through twice, across here. Obviously, it's not 0. We'll talk about that in part C. So where can that work? And the only place that can work really is if it just comes down there like that. So around about here somewhere it would make a little tangent and just touch once. Okay, so we've got to work out the value of k. So this is going to be where 1 over x minus 3 is equal to kx. Alright, so that gives us 1 is equal to just multiplying up by the x minus 3, so kx x minus 3. Expand the bracket, 1 is equal to kx squared minus 3kx. Subtract the 1, 0 is equal to kx squared minus 3kx minus 1. Now, what on earth is that going to do? Well, we've got a quadratic here, and we're after where we're just going to have one solution. So we're going to get one solution, one real solution. And that's going to be where it's only going off with Minjay's snooker ball for the maths bands. One real solution is going to be where you get 1, where your discriminant, your b squared minus 4ac, is going to be equal to 0. And so in this one you obviously got a is equal to k, b is equal to minus 3k, and c is equal to minus 1. So if we sub all that into the discriminant, we've got minus 3k all squared minus 4 times k times minus 1 is equal to 0. So this gives us 9k squared minus plus 4k is equal to 0. So the k can come out of that, and giving us 9k squared, 9k, whoops, just k there, plus 4 is equal to 0. So that gives us k is equal to 0, or k is equal to minus 4/9. Alright, okay. So I think that's all we're required to do at that point on this question. So we've found out what k is. Now it says that k is a non-zero constant, so our answer, which we should make clear, is this one. Don't just give two answers, or you'll only get 2 marks. It must be clear that this one is the answer. Okay, on we go. Part B. Alright, so question 9b. So we can see here we've got a sketch. So I've done this on Desmos. We can see the intersection point here at 1.5 minus 0.667, so 1.5 minus 2/3 is what we should get. But we're going to have to work it out as well. So we've got that where these two are going to intersect, and we've worked out k from the previous part. K is equal to minus 4/9. So we can now say, we can put these two x bits equal, because the y bit's going to be equal where they intersect. And so 1 over x minus 3 is equal to minus 4/9. So just multiply the 9 up here, so that's going to be 9, and multiply the x plus 3 over here. So minus 4x, x minus 3. If we just expand out the bracket, plus 12x there, and we can bring it all to one side. So we got 4x squared minus 12x plus 9 is equal to 0. That then factorizes to a perfect square. 2x minus 3 all squared is equal to 0. So from that we can see that x must be equal to 3 over 2. So that's all well and good, but where is the y? Well, it'd be a lot easier to go back into this one and this one, and this time I'll get it right. So y is going to be equal to minus 4 over 9 times by 3 over 2. Dead easy just to cancel those out. So there's 1 3 there, and there's 3 3's here, and there are 2 2's there. There's 1 2 there, so that's y is minus 2/3. So our intersection is at 3 over 2 minus 2 over 3. Well, clearly you wouldn't be able to have any solutions, because if k was 0, then you'd have y equals 0, and that would just be an asymptote going straight across here, and that would never intersect 1 over x minus 3. So in that case, so you'd have y is equal to 0 would be an asymptote, and then this, so there will be no intersections. Intersections with y is equal to 1 over x minus 3, and y is equal to 0. Sorted.